Good evening, dear students. So this is the third session of vector algebra, and we are going to start with the component of a vector. Okay. So let me share the screen with you. I hope all of you are able to view the screen. Could you please confirm once? Okay, great. So in the components of a vector, so if you recall, in the previous class we discussed about position vector. Now, and also we discussed about the unit vector. Now let us take 3 points in the three-dimensional coordinate system. You see, this is the x-axis. Okay, as you see here, this is OX x-axis, OY y-axis, and OZ z-axis. Okay. Now we are taking 3 points. The first point A on the x-axis, and its coordinate is 1, 0, 0. That means the length of the line segment OA is equal to 1. That's why it is mentioned mod of OA equal to 1 with a arrow, because OA is a vector. Okay, so let me write down the vector properly. So similarly, if we take the point B on the y-axis, okay, and its coordinate is 0, 1, 0, because a point on the y-axis is having its x and z coordinate 0. Okay, so now we can say that the mod of OB equal to 1, because that is also 1 unit, and similarly we get a point C on the z-axis and its coordinate is 0, 0, 1, because any point on the z-axis having its x and y coordinate 0. Okay, fine. So we get mod of OA equal to 1, mod of OB equal to 1, mod of OC is equal to 1. Correct. So now, the vectors OA, OB, OC each having magnitude 1. Okay, each having magnitude 1 are called the unit vectors along the coordinate axis OX, OY and OZ respectively. Okay, so we know the I cap, J cap and K cap are denoted by the unit vectors, right? So what we can say, OA, the vector OA is nothing but I cap. Okay, what is mentioned here? The vector OA is nothing but I cap. The vector OB is nothing but Z cap, and vector OC is nothing but K cap. So this is the unit vectors along OX, OY and OZ are I cap, J cap, K cap respectively. Okay, I hope this is absolutely clear. Now let's go to the next point. Okay, and next point, let me bring the in my digital screen, and followed by I am going to explain you. Okay, now let us consider a point P, having its coordinates x, y, z. Okay, in this three-dimensional coordinate system, so we get a point P having coordinates x, y, z. So now OP is the position vector, correct? Now we are going to find what is that vector OP. Okay, now as the point P is having the coordinates x, y, z, as you see in the adjoining diagram. Now let us take a point P1 which is the foot of the perpendicular from the point P on the plane XOY. So from the point P, if we draw a perpendicular on the XOY plane, how come this is the plane XOY? You see, this is x-axis, this is y-axis. So definitely this plane is XOY plane, and what we are doing is that from the point P we draw a perpendicular to the XOY plane, and this foot of the perpendicular we define as P1. Okay. Now this P1P is parallel to z-axis. What is z-axis? You see, this is z-axis. Correct? Now if you see, this z-axis and P1P are parallel to each other, and we know, we have learned that I cap, j cap and k cap are the unit vectors along the x, y and z axis respectively, and by the definition of the coordinates P, P1P is nothing but OR. Okay, because if we complete this cuboid, if you see, this point is R. Okay, so P1P is nothing but OR, and what is the length of OR? That is Z. So definitely it will be ZK. From a vector notation, P1P vector is equal to the vector OR, and its representation will be ZK cap. Why Z and why K cap? Because Z is the magnitude of the vector P1P or OR, and why it is K cap? Because it is a vector, means we can say the vector OR is along the z axis, and vector P1P is parallel to z axis, and we have learned in our earlier session, if we move a vector parallel to its initial position, the vector remains the same. So as if the vector P1P is nothing but a parallel shifting of the vector OR, as it is a parallel shifting, so the vector remains the same. That means the vector P1P remains the same of the vector OR, and we know the vector OR is along z axis, so hence k cap. In the similar manner, we can show that QP1. What is QP1? QP1, if you see this vector, okay, that QP1 is this one, and that is exactly equal to OS. Okay. Now that is equal to yj cap. How come? Because you see, the point is, what we get is that as a distance y from the origin and along the y axis. So we get the QP1, the vector is exactly equal to the vector OS, and that is equal to yj cap, and OQ vector, that is equal to xi cap. Correct? The OQ vector is xi cap. Now dear students, what we are going to do is that we are going to find that OP. Okay, how we are going to find OP? Let's see. Okay, let me take it from the my already saved screenshot. Okay, so let me do it here only. Okay, so you see OP1, okay, OP1 is vector what? Okay, OP1, the vector is nothing but the addition of OQ plus QP1. Okay, I repeat once more, dear students, you see that OP1 vector or I can tell you in a much simpler manner, what is the vector OP? the vector OP is nothing but OP1 plus P1P. Let me use a different color. Suppose let me use a color called green color. So we are going to find OP. OP is nothing but OP1, this vector, plus P1P. Right? That's what we have written here. OP is equal to OP1 plus P1P. Now, what is OP1? OP1 vector is nothing but the addition of the vector OQ and QP1. Now, what is the vector OQ? OQ we have seen earlier, it is xi cap, and we know that QS vector or QP1, sorry, not QS, QP1 vector is nothing but OS, which is yj cap. So we get OP1 is equal to xi cap plus yj cap. Now what is OP? OP is equal to OP1 plus P1P. OP1 we have just learned, it is xi cap plus yj cap, and P1P we have derived earlier, here it is, that is equal to zk cap. So we get the vector OP, and if we represent that vector OP as R, vector R, we get that vector R is equal to xi cap plus yj cap plus zk cap. Okay, this form of any vector is called its component form. Here x, y and z are called the scalar component of the vector R, and xi cap, yj cap and zk cap are called the vector component of R along the respective axis x, y, z respectively. Okay, and you know, dear students, that x, y, z are also terms as the rectangular components. Okay, why they are rectangular components? You see, it forms a rectangle. Okay, and hence these are known as the rectangular components. I hope this is very clear that how we derive the vector OP, okay, in terms of I cap, j cap and k cap. So now let's proceed to the next one. Okay, so we are going to find the magnitude of the vector R. So we found the vector R, but what will be the magnitude of this vector? So let's derive it here. Okay, so if you recall the diagram, so let me keep the diagram here as well. Okay, we know the vector R is equal to xi cap plus yj cap plus zk cap. Okay, and we have derived this thing. Now we are going to find the magnitude of this vector OP. So now the magnitude of this vector OP will be nothing but the magnitude, how we can derive this thing is that first we derive the magnitude of the vector OP1. OP1 is equal to square root of OQ square plus QP1 square from the Pythagoras theorem, and that we get as square root of x square plus y square. I hope it is clear. And then in the right angle triangle OP1P, OP1P is also a right angle triangle. And which one is the right angle here? This is the right angle. This one is the right angle. So then OP is the hypotenuse. So what we can get, dear students? So we get P1 square is OP square is equal to OP1 square plus P1P square. So here it will be OP, modulus of OP. So that is equal to square root of x square plus y square plus z square. Okay. So now that we are able to derive from the Pythagoras theorem. So we get the length of any vector R xi plus xi cap plus yj cap plus zk cap is given by mod r equal to mod of xi cap plus yj cap plus zk cap is equal to square root of x square plus y square plus z square. Okay. So now this is the way we can find the modulus of the vector r. Now the magnitude of the vector r. Okay. So in case of any doubt, never hesitate to let me know about it. So we derive the vector r in terms of I cap, j cap and k cap, and then we find the magnitude of this vector r. Okay. These are very important questions, are definitely going to come from this. So please make a very careful note of it. Okay. Now let us see some algebraic operations on this. Okay. So let me bring it here. So let us take two such vectors a and b. Okay. And in the component form, how we can express the vector a? The vector a is expressed in a component form as a1i plus a2j plus a3k. a1i cap plus a2j cap plus a3k cap. So that is the vector, that is, just a minute, that is a vector a. This is the vector a. And vector b is b1 I cap plus b2 j cap plus b3 k cap. Now the sum of these two vectors, that a plus b, is nothing but the sum of the corresponding components of I cap, j cap and k cap of these two vectors a and b. So what will be a plus b? It is the sum of the I cap component of the vector a, which is a1, plus the I cap component of the vector b, which is b1. So it is a1 plus b1 I cap. Similarly, the j components would also get added, that is a2 plus b2 j cap and a3 plus b3 k cap. So this is the way we can find the sum or resultant of the vectors a and b, and we can find the magnitude of the vector a plus b, that is mod of a plus b, that will be equal to square root of, for example, if we need to find the mod of magnitude of the vector a plus b. So magnitude of the vector a plus b will be equal to square root of the I component square, that is a1 plus b1 square, a1 plus b1 square plus j component square, a2 plus b2 square plus k component square, a3 plus b3 square. Okay. Now the difference of the vector a and b, that is symbolically represented by a minus b, and that is equal to a1 minus b1 I cap plus a2 minus b2 j cap plus a3 minus b3 k cap. Now two vectors in the component forms, represented in component forms, will be equal if their I components are equal, j components are equal and k components are equal. For example, we can say the vector a is equal to vector b if a1 equal to b1, a2 equal to b2 and a3 is equal to b3. That means a1 equal to b1 means what? The I component of the vector a is equal to the I component of the vector I component of the vector a is equal to the I component of the vector b. Similarly, I component of the vector j component of the vector a, that is a2, is equal to the j component of the vector b, that is b2, and similarly a3 equal to b3, that is the k component of the vector A, that is A3, is equal to the k component of the vector B, that is B3. Now the next one is that the multiplication of a vector A by any scalar lambda is given by lambda A is equal to lambda A1A plus lambda A2J plus lambda A3K. So lambda will be multiplied with each of this coefficient of I component, j component and k component. So these are the very useful results when there are two vectors A and B represented in the component form. Okay, I hope things are clear. Now let's go to the next point. Okay, so I'm going to make some remark here, and very important remark, and I want you to notice it. Okay, so as you see here, dear students, we can observe that whatever be the value of lambda, the vector lambda A is always collinear to the vector A. Obviously, we have learned in the previous session that the vector A, vector Ka are parallel to each other. It is just a k times of the vector A. Ka is a vector which is k times, its magnitude is k times that of the vector A. So what I am saying is that whatever be the value of lambda being a real number, okay, the vector lambda A is always collinear with the vector A. In fact, two vectors A and B are collinear if and only if there exists a non-zero scalar lambda such that B is equal to lambda A. Okay, B is equal to lambda A. If the vectors A and B are given in the component form, that is A equal to A1 I cap plus A2 j cap plus A3 k cap, that is the component form expression of the vector A, and same for the vector B is equal to B1 I cap plus B2 j cap plus B3 k cap. And if these two vectors, that means the vector A and B are collinear, then what we have just observed, B equal to lambda A, so that means B1 I cap plus B2 j cap plus B3 k cap is equal to lambda into A1 I cap plus A2 j cap plus A3 k cap. So that means what? Definitely that B1 has to be equal to the lambda A1, because we know two vectors are equal. That means their corresponding I component, j component and k component will be equal. That means B1 should be equal to lambda A1, B2 should be equal to lambda A2, B3 should be equal to lambda A3. So that means what? B1 by A1 is equal to B2 by A2 is equal to B3 by A3, that is equal to lambda. That is the first observation we get. Now the second one, if A equal to A1 I cap plus A2 j cap plus A3 k cap, then A1, A2, A3 are also called the direction ratios of the vector A. Okay, got it? In case it is given that L, M, N are the direction ratio of a vector, then Li plus Mj plus Nk, that is equal to cos alpha, cos beta, cos gamma, because we know L equal to cos alpha, where alpha is the angle made by the vector in the positive direction of x-axis. Similarly, beta is the angle made by the vector with the positive direction of y-axis, and gamma is the angle made by the vector with the positive direction of the z-axis. So we get Li cap plus Mj cap plus Nk cap is nothing but cos alpha I cap plus cos beta j cap plus cos gamma k cap is the unit vector in the direction of that vector, where alpha, beta, gamma are the angles which the vectors makes with the x, y and z axis respectively. I hope you got a very clear idea that whatever the remarks I talked about. Now let's go to the next point, dear students, and I am going to discuss that. So let's take one example here. Please open your notebook and you also do the example along with me. Okay. So example here is that, dear students, is that here let me read out the question first. Find the value of x, y and z so that the vectors A, which is expressed as xi cap plus 2j cap plus zk cap, and B, that is equal to 2i cap plus yj cap plus k cap, are equal. We know two vectors are equal if their corresponding I cap components are equal. That means x should be equal to 2. That x, you see, this x has to be equal to 2 because both are the I component of the vector A and B respectively. Similarly, 2 should be equal to y, that is y is equal to 2, and z should be equal to 1. K cap means nothing is there, means 1. So z equal to 1. So these are the values of x, y and z. I hope you got a very clear idea about this question. So now let me go to the next point. Okay. So let's go to the next question. So dear students, so let me read out the question first and after that I will explain. Let A is the vector represented as I cap plus 2j cap. B is the vector represented as 2i cap plus j cap. Is mod A equal to mod B? And the second question, are the vectors A and B are equal? So the point is that what is the mod A? That is the square root of I component square plus j component square plus k component square. So for the vector A there is no k component, so it is I component square, that is 1 square, plus j component square, that is 2 square, that is equal to square root of 5. Similarly, mod of B is equal to square root of I component square, that is 2 square, plus j component square, that is 1 square, plus k component is nothing, 0 square, we can say the square root of 5. So we see the vector magnitude of the vector A is equal to the magnitude of the vector B, both are equal to square root of 5. But the vectors are different, their magnitudes are same. Okay, why the two vectors are different? Because their components are different. You see, in case of the vector A, the I component is 1, and for the vector B, the I component is 2. This 1 is not equal to 2. Hence, we can say the vector A and vector B are not equal. Similarly, we can say the j component of the vector, which is 2, is not equal to j component of the vector B, which is 1. So they are not equal. So hence the vector A and B are not equal. However, their magnitudes are same. I hope you got a very clear idea about this question. And now let's proceed to the next one. In fact, next question. Good question. So these questions is a very practical questions, and sometime you need to find a unit vector in the direction of a general vector, which is represented in the component form. So very important one, please note it down. Very simple also. The question is that find unit vector in the direction of the vector A, which is represented in the component form as 2i cap plus 3j cap plus k cap. Now we know from our previous class, you can look into our previous video lectures available in YouTube, that the direction, the unit vector in the direction of a vector A is given by a cap, that is equal to the vector a, that is with the arrow, divided by the magnitude of this vector, okay, that is the mod of a bar. So as the vector a is given, we can find its magnitude, that is equal to square root of I component square, that is 2 square, plus j component square, that is 3 square, plus k component square, that is 1 square, which is turning out to be square root of 14. Now, as we just learned, not just learned, earlier also we have discussed in the previous section, that a cap, that is the unit vector in the direction of the vector a, that is equal to the vector a, which is 2 cap plus 3 cap plus k cap, whatever is there, divided by mod of the vector. That means the magnitude of the vector, which we found out few seconds back, is square root of 14. So the vector become 2 cap plus 3 cap plus k cap by square root of 14, and we can simply write is that 2 by square root of 14 cap plus 3 by square root of 14 j cap plus 1 by square root of 14 k cap. Okay, so these are the steps to be followed when you need to find the unit vector in the direction of a vector. I hope it is clear, dear students. Okay, now let's go to the next one. Next question, so let us go. The question here is that, first let me read out the question. The question is that find a vector in the direction of the vector I cap minus 2j cap. That you can easily find it out. Okay, so that how we can find it out? That we know if a is a vector, then its unit vector is a by mod a. A to we know I cap minus 2j cap divided by mod a is square root of I component square, that is 1 square, plus j component square, that is minus 2 whole square, plus k component square, which is 0. K component is not there, na? So we get 1 by root 5 I cap minus 2 by root 5 j cap. But what is the question? I didn't read the question completely in the first time. Now let me read out. Question is that find a vector in the direction of the vector I cap minus 2 j cap that has magnitude 7 units. This type of questions are also very relevant, come in the examination, especially in the board examination. So to find answer to this type of questions, first you need to find what is the unit vector in the direction of the vector A, that is we found it out 1 by root 5 I minus 2 by root 5 j. Now that vector, if we multiply it by a scalar called 7, we will get the answer. That means our answer is 7 a cap. Why so? Because the question is that find a vector in the direction of the vector. The moment it is direction of the vector, first we will find what is the unit vector in the direction of the given vector, that is a cap. But next part is that has magnitude 7 units. That means whatever the unit vector we got, we multiplied that vector by a scalar 7. So that's why the actual answer to this question will be 7 a cap. A cap we already found it out from here, that is a cap. So 7 into 1 by root 5 I cap minus 2 by root 5 j cap, that is equal to 7 by root 5 I cap minus 14 by root 5 j cap. I hope you got a very clear idea. So this question and the previous question, that is the finding the unit vector in the direction of a vector, and second one which is seen in front of the screen now, that is to find the vector in the direction of a given vector but with a specific magnitude. In this case the magnitude is 7 units. These are the steps to be followed to solve this kind of questions. I hope you got a very clear idea, dear students. So now let's move to the next question. So Sorry. So next question, I am placing it here, dear students. The question here is that, let me read it out. Okay. Find the unit vector in the direction of the sum of the vectors. Quite simple. First we find the sum. The vector a and b is given. So a plus b is quite simple. Addition of their corresponding components, that is the vector c, if we consider as a plus b, it will be the addition of the I component of the vector a plus I component of the vector b, means 2 plus 2 I cap, that is 4 I cap, which is written here. Similarly, for j component of the vector a is 2 plus j component of the vector b is 1, 2 plus 1, that is 3 j cap, and minus 5 k cap plus 3 k cap, minus 5 plus 3, that is minus 2 k cap. And after that magnitude we can find it out, because that was the question. We need to derive intermediate, that is mod c, and after that we need to find the unit vector in the direction. So as simple as that. So we should divide this vector by square root of 29 and we get the result. Let me bring it here so that it will be absolutely clear. Okay. Okay, so this one, that is the required unit vector. Let me bring the entire thing, so please have a look at it, clearly, that how we have derived. So the question is to find the unit vector in the direction of the sum of the vectors. So as if we add a plus b, we get c, we get 4 I cap plus 3 j cap minus 2 k cap. We need to find a unit vector in that direction. So simple thing is that vector, that is 4 I cap plus 3 j cap minus 2 k cap, divided by the magnitude of that vector, that is square root of 4 square plus 3 square plus minus 2 whole square, that is actually 2 square. It turned out to be square root of 29. So we divide by this one and we get this one, and that is the answer to the given question. I hope you got a very clear idea, dear students. So now let me go to the next question. So dear students, in this one the question is that write the direction ratios of the vector A expressed in the component form as I cap plus j cap minus 2k cap. Hence, calculate its direction cosine. Direction ratio is very simple. We have learned earlier. If we represent a vector as xi cap plus yj cap plus zk cap, then its direction ratios are x, y, z. That is the I component, j component and k component of that. So the given vector is I cap plus j cap minus 2k cap. So its direction ratio will be 1, 1, minus 2. Now that is the direction ratio. That is fine. So that we have done. But to find the direction cosine, what you need to do? We need to divide a by square root of a square plus b square plus c square. That is square root of 6. That is the mod of the vector r. So a will become 1 by square root of 6. M become b by mod r, that is 1 by square root of 6. And n become c by mod r, that is minus 2 by square root of 6. Where square mod of r equal to square root of 6. Now if we how to make sure that we found the direction cosine correct is that if we make a square of this component plus this component plus this component, we must get 1. Obviously square of 1 by square root of 6 plus square of 1 by square root of 6 plus square root of minus 2 by square root of 6, that will actually give you 1, and it gives us confidence that we found the direction cosine correctly. Okay, so I repeat once more. If L, M, N are the direction cosine, then we get L square plus M square plus N square equal to 1. Okay, so I hope you got a very clear idea. Now, dear students, we are going to discuss about the vector joining 2 points. Okay, the next topic. So let me bring this one here in the screen and then let me describe. So the vector joining 2 points. Okay, so as you see in the adjoining diagram, so there are 2 points P1 and P2 as you see in the screen. Now the point P1 is having the coordinates x1, y1, z1, and the point P2 is having coordinates x2, y2, z2. Now what is our target? Our target is to find the vector P1, P2. That is what is our target. Now joining the points P1 and P2 with the origin O, and if we apply the triangle law, we get this one. So we first join the point P1 and P2 with the origin O. Okay, then we get one called OP1, another one we call OP2. So now what is OP1 plus P1 P2? OP1 plus P1 P2 is nothing but OP2, and that we get from the triangle law. Okay, any triangle, so that is a cyclic nature. Okay, we have already discussed this thing earlier. So in simple terms I can say vector addition. Okay, using the properties of vector addition we can get that P1 P2 is nothing but OP2 minus OP1. OP2 we know in the, as you know, the coordinates, coordinates of the point P2. That means we can find what is the position vector OP2, that is x2 I cap plus y2 j cap plus z2 k cap. Similarly, OP1 is that x1 I cap plus y1 j cap plus z1 k cap. So now we know we have learned earlier the properties of, if A and B are given represented in component form, then how to find A plus B. Similarly, we found A, in this case it is A minus B, the difference of the I component, j component and k component. That is it, x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. And what will be the magnitude? That is square root of I component square plus j component square plus k component square. That means actually x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. That is nothing but the distance formula also, if you remember, between 2 points. Okay, so I hope you got a very clear idea about this vector joining 2 points. Okay, now the next point what we are going to discuss is an example based on whatever we have discussed. Okay, so let me bring the example here only. So find the vector joining the points 2, 3, 0, P and Q, minus 1, minus 2, minus 4, directed from P to Q. So what will be PQ? Very simple thing is that this one, based on this one, the x component of the point Q, that is minus 1, minus x component of the point P, that is 2. So minus 1 minus 2 I cap. So minus 1 here, minus 2, actually minus 1 minus 2. Then similar manner we can find the j component of PQ, that is j component of the point Q, that is minus 2 minus j component of the point P, that is 3. So minus 2 minus 3 j component, j cap. Similarly minus 4 minus 0 k cap, and we get PQ the vector as minus 3 I cap minus 5 j cap minus 4 k cap. I hope you got a very clear idea, dear students. Now let's move to the next one, and that is the section formula. So dear students, in the section formula, what we are going to discuss is that, so let us consider the 2 points P and Q. Okay, as you see in the adjoining diagram, the points P and Q also mentioned. Okay, so let's take point P and Q. Okay, so 2 points represented by the position vector OP and OQ, as you see in the diagram. So OP is denoted by the vector A and OQ is denoted by the vector B with respect to the origin O. Then the line segment joining P and Q may be divided by a third point, say R, in the ratio m is to n. So let me explain about the ratio internally. Internally means what? If you join PQ and then find the point R, the point R should be in between PQ. That is called the internally. I repeat once more, the line segment joining P and Q may be divided by a third point, say R, in two ways. Internally, in which the point R must be inside the segment PQ, and externally, on which the point R will not be exactly within PQ but external to PQ, and that you can get by extending the line segment PQ. I will come after some time. So here we intend to find the position vector OR for the point R with respect to the origin O. Obviously that is called OR, that is the position vector of the point R, and let us describe this by R, the vector R with a arrow sign. When R divides, there are two cases here, as I said earlier, that internally and externally. The first case is that when R divides PQ internally, as it is rightly described in the adjoining diagram. So let's R divide PQ in such a manner that m times R cube is equal to n times PR, where m and n are positive scalar quantity. We say that the R divides PQ internally in the ratio m is to n. Okay, how come? PR is to R cube is equal to m is to n. Okay. Now, if we look into the triangle ORQ and triangle OPR, it is quite clear to understand that RQ is equal to OQ minus OR from the triangle now, that is B minus R, and PR equal to OR minus OP, that is R minus A. And we have just learned that m into RQ is equal to m into RQ is equal to n into PR. So that's one we have applied here, that m into RQ, that is B minus R, is equal to n into PR, that is R minus A, and after simplification we get the vector R is represented something like this. M into B plus n into A by m plus n, and similarly we can get the position vector of the point R. But how to do this thing? So how to get it? M times the position vector of the point Q, that is MB, plus n times the position vector of the point P, that is A. That is why it is MB plus NA divided by m plus n. That is the case 1 when R divides PQ internally. Now let's look into the second case, case 2, where R divides PQ, externally. Okay, so let's see this one. Sorry. Just a minute. Now, dear students, in the case 2, when R divides PQ externally, what does it mean by externally? That externally means the point R is not inside the line segment PQ, but if you extend PQ, you will get the point R in the same extended line segment. You see, R is not in between PQ. PQ is here, right? In between PQ is here, but it is not easy. But if you extend that PQ, you will get that R here. Okay. Now, that when we say that R divides the line segment PQ externally in the ratio m is to n, that means PR divided by QR is equal to m by n. And after that, we can make use of this triangle law. Similarly, the way we have done, we can get the vector OR is represented as mb minus na by m minus n. Same thing, that m times into b minus n times into a by m minus n. If R is the midpoint, definitely it is a special case of the internal segment, then m should be equal to n, midpoint, because it will be equally divided. And for that we need to go back to the previous case here. If we get the R is exactly in between PQ, then m equal to n, then what will be the vector R? The vector R will be m and n are same, so mb plus ma by m plus n. So mm will get cancelled, so we get a plus b by 2, which is actually shown it here. Okay. I hope you got a very clear idea, dear students. Okay. Now let's go to the next one. Okay, so let's look into one example. Okay. Now the question here is that let us consider 2 points P and Q with position vectors given. OP equal to 3a minus 2b and OQ equal to a plus b. Find the position vector of the point R which divides the line segment PQ in the ratio 2:1 internally and externally. Very simple. Position vector we know. So that internal division, it is m into position vector of q. So 2:1, 2 into position vector of q, that is a plus b, plus 1 into position vector of p, that is 1 into 3a minus 2b by 2 plus 1, that is 3. So it comes to 5a by 3. Now externally it will be same thing with a minus sign. So m, that is 2 times position vector of the point q, that is a plus b, 2 into a plus b minus 3a minus 2b, because 2:1, so that's why it is minus 1 by 2 minus 1, and we get 4b minus a. I hope you got a very clear idea by means of this example. Okay, dear students, so now let's go to the next point. Okay, next question what we are going to discuss, dear students, is here. So that the points A, B and C are the vectors of a right angle triangle. So how to mean, that means it will be something like this. Okay, so it will be represented by this thing. But how to prove this thing? Okay, so first we find the AB, BC and CA. We know how to find AB, the position vector of the point B minus the position vector of the point A. So that means what? The component of B, I component of B is 1 here, minus I component of the vector A, that is 2. So 1 minus 2 I cap. Similarly, the others has been find it out here. After that, what we need to do? We need to see that we need to find the magnitude of these three vectors. Okay, so if we find the magnitude of these three vectors, we will see some interesting thing here. Okay, so what is that interesting thing? So let me show it here. Okay, so we see that BC square plus CA square, that is equal to 6 plus 35 respectively. That is BC square plus CA square, that will be equal to 2 square plus 1, that is 6. Okay, and minus 1 square plus 3 square plus 5 square. Okay, that is equal to 35. So 6 plus 35, that is equal to 41, which is nothing but that mod of AB square. So what we get, AB AB is something like this, that is the hypotenuse. Okay, and we get BC and CA. So BC and CA something like this. Okay, though the drawing is not up to the scale, but you understood the intent. So as we see that the magnitude of one vector square, the square of the magnitude of one vector is equal to the sum of the squares of the magnitude of the other two vectors. So these three vectors form a right angle triangle. Okay, dear students, so I hope you got a very clear idea. With this note, I would like to conclude the class for today. In the next class, we will start the next point, that is called the the product of two vectors. Okay, so with this note, let me conclude the class here, dear students. Thank you very much. In case you have any question, please do let me know. Do you have any question, dear students?
No, sir.
Okay, all right. Thank you very much. Bye.